This video will be covering requirements 4 and 6 of the Scouts BSA Programming Merit Badge. Number 4 is intellectual property. We will go through A, B, and C. On number 6, we're going to discuss 3 opportunities that require knowledge in programming, but I am going to ask after this video, as one of the assignments for this video, is that you pick one that might be of interest to you, and we can discuss it later. But we will go through several examples so you can take a look at them. Okay, we'll get started with 4. Intellectual property we're going to cover by, I prefer the Simple English Wikipedia. It simplifies things, which I think is very helpful. Intellectual property in general, the idea is that you're protecting something that was created. So just as in, if you create a beautiful piece of art or some music, software can also be protected. And it's intellectual property in the sense of it's something created by somebody, intellect, mind, that is your property. So there's several different types of it. The requirement asks to go through 4 common types. And here they have 5 listed, but we're going to go through copyrights, trademarks, patents, and trade secrets. That's the 4 main ones we're going to hit. So, copyright. These are all very similar things. They differ in what they are protecting, the different things that they're protecting. So copyright is focusing on a work. So most commonly, book, movie, website, picture, song, or a website. I think I already said that. The best way I think to understand this is just look at an example. Up here are 2 pictures. One is on the right is the picture of, I'm sure many of you have seen the movie Cars. So that's the movie that came out, the original movie Cars. Actually, I think that's Cars 2. Yeah, that's Cars 2. So it came out, and then it apparently got copied by someone who was not Disney, so some sort of a knockoff, decided that they wanted to try to take a lot of the same ideas because they knew kids liked them, and then make their own movie out of it. Well, Disney found out about this, probably rightly got upset, sued the company. They had to go to court because Disney didn't appreciate them taking their ideas for Cars and then making them into their own and then making money off of that. So that's the example of a copyright. And in this case, it'd be a movie that they copyrighted, Disney did. Next is trademark. Again, very similar. You're protecting an idea, except with a trademark, it usually comes in the form of a name, word, phrase, symbol, logo, design, or picture. A very famous one, well, maybe not famous in San Antonio, we only have one, but In-N-Out Burger. And so at least I know there's one on the west side here that, they have a very distinct symbol. They have the red and the yellow here in a certain pattern, in a certain way, with a certain font, right? Well, at one point, apparently, there was a company that wanted to somewhat copy that as In-N-Out Cleaners. And it was not the same company that did it. And so they created their logo, and as you can see, tried to make them very similar, the cleaners versus the burger. Well, the burger place had it first, and they didn't appreciate that. So again, they went to court, and they worked it out, I assume, somehow. But in the end, probably In-N-Out, the burger chain, won because they had the original trademark. So that's a trademark. The third out of the 4th here is patent. Patent, again, same idea. You're protecting an idea, but this time usually related to an invention and an inventor. So a case to go over here is a shoe, actually. So you can see on the right, this is a picture of a shoe that was created by Walmart. Now on the left is a picture of a shoe that Nike had patented. So they had laid claim to the idea. So this, like the other ones, went to court. And then Nike and Walmart had to battle out about whether it was appropriate for Walmart to have a very similar to shoe to Nike. So that is the discussion of a patent. And lastly, a trade secret. Trade secret is it's referring to formulas or designs or recipes. The most common one I think of is the Coca-Cola trade secret of what's actually in a Coke, right? So it's a secret thing to the Coca-Cola company because they don't want other people copying their recipe and their idea for what a Coke should taste like. They came up with it, so they feel that they should have the exclusive right to be able to make a Coca-Cola the way that they think they should. So that is that's the four types of intellectual property that it wanted us to go through. The reason that's important for computer programs is that uh, computer programs are protected in much the same ways as music or trademarks or patents are, to where the creator of a program lays claim to it. And they say, I created this, and here's the things I want to do with it. And so here in a bit, we'll talk about licensing and owning and freeware and open source. Before we get to that, though, there's something very important I want you to understand about intellectual property and software. We're going to go to a site called Stack Overflow. Stack Overflow is a site that I use all the time at work. It's a way to get questions answered from programmers like myself by other programmers who may have more experience in a certain language or in a certain area. So this is an example up here of a question that somebody had posted that I needed to know the answer to as well. So somebody had posted this question, it was 7 years ago, but still very applicable to what I was doing at work. I was using C++, and I needed to check if a file existed or not. And so I Googled this, came up with somebody had asked this question, same one I needed to know, wonderful news, and I went through a few answers here. I saw a good simple one that I liked, and then I would decide to use that in my program. Now, I work for a company that is going to make a proprietary commercial medical device, but I am still allowed to look at this code right here and use what they are saying as an answer to something that I had in the program I was writing. The reason I'm able to do that is that on Stack Overflow, anything that is posted here is freely available. It is open source and it is free. Anything that a person chooses to post here. And that's very important because as you're learning programming, there will be a lot of times that you're looking for answers that they will be available freely and they're not necessarily copyrighted. So you need to use your best judgment when choosing to copy and paste from a site like that. But just remember that a lot of the examples that are out there are meant to be used. Now, there's some things that you obviously, you want to take protections of because that's how they make their money. Something like Microsoft Excel and Word, Microsoft makes their money off of a subscription or buying those programs. Which kind of leads us into here, the difference between licensing and owning software. Let me bring up a tab that I think gives a good summary of this with something that hopefully everybody's pretty used to. So with Microsoft Office, there's two ways that you can buy Office. You can either subscribe to it or you can own it. The left two options here are the subscriptions. You have to pay a certain amount for a time period, a year. That's $69.99 here and the $99.99. So if you pay that, you get all these apps down here, Word and Excel, PowerPoint. Or you could choose to own it, which on the right is this one-time purchase. We have to pay more, but you pay it one time. So that's the difference between licensing and owning. Licensing is software that the company wants you to purchase it for a period of time, and then owning it is something that it's a one-time thing, like this here. So that's just one example of Microsoft Office, but there's plenty of other examples out there with different applications. Okay, and the last thing here is discuss the differences of freeware, open source, and commercial. Let's focus first on freeware and open source and the differences between those. We'll do commercial in a bit. Freeware is free as in they're going to give it to you, just like it's a free dollar bill that you found on the ground that no one has laid claim to, or a free lunch that somebody feeds you for whatever reason. It's free. It doesn't cost any money. That's free in the sense of software, but you'll also hear it in the sense of it's free in the sense that it's open. Open source is the other type of free. So when people say freeware, they usually mean it's free, you don't have to pay anything. But then when people say open source, that means something different. That means that the source code of a program is available for you to download and look at. So, just like the other the other programming languages, the examples that you will do, there is source code that defines how, Microsoft Windows works, or how Microsoft Word works, or Excel. And open source means that the source code is given also in addition to the program itself. Now, why would you want to do this? The reason you'd want to do that is because maybe you just enjoy programming and you think that what you can do can be of help to a lot of other people, especially if they helped you with it. If they helped you with it, you could create something of very high quality that you enjoyed doing, and that's why you would share the source code to it. So a very famous example of open source is Linux. So Linux, you hear about running on servers. It's not as common with laptops and personal computers, but it's the basis for a lot of servers. So something that you may be a bit more familiar with is Google Chromium OS. So Chromium OS is the basis for Chromebooks. So this is a picture of using the Chrome OS, and it's similar to Windows and Mac OS, right? You've got a start menu type thing and applications and windows that you open and close. Chromium OS is a free and open source operating system that is made by Google. It's the basis for their Chromebooks. So why would Google do this? I think they did it because Google's focus was to make money off of the Chromebooks themselves and other things that they own, like YouTube. And they wanted to help out the world a little bit by having something that was free and open source so everybody could improve it and then make it into other things if they wanted. Just like Linux, which is, there's all types of different types of Linux out there. And that's because it's free and open source. So somebody might get it and say, I want it to run on this really, really, really small device like a Raspberry Pi. And then you could do that without having to pay for it because people are just trying to have fun or teach. So a custom version of Linux might be appropriate for that. So that's free and open source. And the last one that it mentions here is commercial. Commercial is like what we were just looking at with Microsoft Office. It's made by a company, you pay for it, and then you can either subscribe or own it. So they are there to make money, as opposed to some other types of software projects which are there to, just to help the world in general and to give people a fun hobby to do. So different types of software are out there. Okay, and I think the other one we're going to hit here is careers. So what we're going to go over is just a set of careers that are out there, and then it'll be up to you to pick one out of the ones that we go through, learn about it a bit more, and then we can discuss it. So I think this is the site, which I will list the address in the YouTube video down at the close to the comment section, so you can get to this as well. So with computer type degrees, there's a few different types of degrees and jobs you can get. I got a degree as a computer engineer, and that's what I work as. So I work with software on medical devices that it's responsible for looking at things from a medical, it's actually an ultrasound probe with a laser attached to it to look for certain types of cancer. And I'm going to help display the images that help the doctors and the people who are looking at those images to decide if something is cancerous or not. So anyway, that's me. So I'm a software engineer, but there's also other types. There's a web developer. So a web developer, you're focused on websites. So you're focused on how they look. You've got this nice green bar down here and the icons and how you navigate it. That's a web developer. So that's another type of job you can get. I know a little bit about web development, but not near enough to, to create a web page like this very quickly. I'd have to learn. Computer programmers, to me, are actually very similar to a software engineer. I think that they're saying that they would focus more on things like C++ and Python, the languages, but to me, computer programmer is a type of a web developer and software engineer. A database administrator is someone who is working with databases, which are it's a computer term for a whole bunch of data in one place that people have to access and get to. So as an example, say a bank has a huge database of customers, money, when they put in money, when they took out money. All of that data is stored somewhere. It's kind of like a huge filing cabinet. And a database administrator's job would be to understand how that filing cabinet is put together and how to put records in and take records out. That's another type of a computer job. There's also a hardware engineer, to where, yes, it is hardware, so it's those, like those green boards that you see, but you're focused on the software that helps run those green boards. So it's not things maybe that people would see as much with a monitor plugged into it, but it's software that makes that work. So, for example, on the AirPods that I have in my ear right now, they actually have software that's on them, and that software is listening to what I have to say. It turns it into an audio signal, and then maybe does some filtering on it, gets rid of the fan over here, and then sends it over Bluetooth to the computer to where it can be recorded. So, although there's no monitor, something that you see on my AirPods, there is software that's running in there, and that would be close to what a hardware engineer does. And in addition to that, you'd understand a little bit about how the AirPod was built and the mechanical and electrical components of it. A network architect is someone who deals with networks, which is a fancy word for connecting computers together. So, at the schools that you go to, there's a whole bunch of computers everywhere, right? Well, they need to be able to talk to each other and the internet. And networking is bringing all of those things together. So there can be wireless networking. There can be wired networking, though, to where it's a physical cable that connects computers to different hubs and switches and routers, and all with the purpose of connecting the computers to each other so they can talk to each other and the internet. Networking is very important these days because we rely on computers talking to each other all around the world, whether it's an iPhone or an iPad or my computer here, all being able to want to talk to, say, my kids want to talk to their cousins in Houston. Networking is all about getting that information from us to them and back. A systems analyst is someone who is deciding what type of computers might be good, say, for a business that's just starting up. So a systems analyst might say, well, okay, you have an office that's going to have 20 employees. You're going to need this many computers and this many servers. And they'll work with somebody who does networks to be able to say where to put the wires and how to connect them together. And then what operating systems should be installed on it, what apps people need, things like that. So it's making all the computers work together and then buying what you need. So in general, the skills that are good to have for any of these types of jobs are these listed here. So math. Math is a huge part of programming. Anytime that you start to program, you're going to run into numbers. So multiplications and all that, the simple stuff, all the way to understanding types of curves. And like with games, you have to understand actually some physics and some math about how to draw things, because we're trying, in games, you want to make things semi-realistic. So there's a lot of math underneath that. Science and engineering, in particular, like it says, mechanical and electrical. A lot of things that software runs on are mechanical and electrical things, AirPods, cameras, phones. So you put them together with plastic or metal components, and then you have electrical components, those little green boards with all the mazes on them, and then software as well. So science and engineering go along with the computer part in creating a device. Computer languages are something that you, of course, have to be good at, but the truth is that you learn languages as you go if you were to choose to become a programmer. So I know, a set of languages, maybe 5 or 10 really well, but there's a lot of languages I don't know. But once you understand 1 or 2 languages really well, you can pick up on others as necessary. So You would get a start on this by taking a programming class in a language, so a Python class, or a C++ class, or a web development class, and you would learn a language, but continue to learn throughout your career. And then, of course, the things that they say are important in all jobs, critical thinking, problem solving, creativity, communication, all the stuff that's important in any job. I think communication is very important, especially being able to hear what other people have to say, think for yourself about what they mean, and then responding politely and appropriately if you agree or disagree and work through problems. Every day at work, the reason I keep going in and the reason I like my job is that there's a lot of problems to solve. And sometimes the problems were even created by me. You know, a few months ago, whenever I did something silly in computer code, or, you know, it was something that we just didn't think about, or it was a broken piece of hardware. So there's a lot of problems to solve every day, but that's what I enjoy about my job too. So for requirement 6, we've gone over a few here on this site. I would like you to choose one out of the ones that we went through, and we can talk about why it might be of interest to you. So I think that's it for this video. This was requirements 4, so A, B, and C we walked through, and then 6 we went through that, and that is this video.